Hello, welcome to the 10th week of the recitation for EE2423 network theory. This week's recitation will discuss some problems on sinusoidal steady-state analysis. Okay, so I have prepared 3 problems for this recitation, and let's see the first problem. So I have voltage source, capacitor, resistor, and this is 30 ohm. Capacitor is 1 microfarad, and one inductor 1.2 millihenry. And let us define the voltage across this inductor as V0. Okay, and what is known is that Vg, or the voltage source, is sinusoidal instead of DC, right? So we have an AC voltage source, Vg of t, so we have t because it is actually time varying. The voltage, the instantaneous voltage, it depends on the time. So Vg of t is 40 sine 50,000 t volt. Okay, and the question is, what is V0 of t? Okay, so you might be wondering why we call it steady state analysis, since we have time varying voltage, for example, right here. It's because we assume that the frequency, which is right here, omega, it's fixed. So since omega is fixed, then all of the analysis, so all the currents, all the voltages, since the frequency is fixed, then we can determine their exact value regardless of the frequency, because it is fixed. So since it is fixed, then we do not really care with the frequency, so we can do the analysis in a steady state fashion. All right, okay, so let's solve the problem. Let me label this one as Z1, Z2, Z3. Okay, so in sinusoidal steady state analysis, we use the term impedance instead of resistance, because we have complex numbers, complex quantities in our analysis, so we call it impedance. So for this capacitor, we label it as Z1, resistor as Z2, and this inductor as Z3. So first, let's find out what is Vg. Vg is 40 sine, but our convention is not using sine but cosine. So let's express Vg using cosine function instead of sine. So 40 cosine omega t, still 50,000 t, but since we have cosine here, then we have additional minus 90 degree there, and they're the same. And we should express, since we fix omega at 50,000 radian per second, and we can express this into polar form. So 40 with an angle minus 90 degrees, right? Or 40 e to the power minus j 90 degrees, and you can use Euler identity. So 40 cosine minus 90 plus j sine minus 90. So cosine minus 90 is 0 and sine minus 90 is minus 1, so minus j40 fold. Okay, now let's compute z1. What is z1? Z1 is 1 over j omega c, right? So 1 over j times 50,000. C is 1 micro, so 10 to the power of minus 6. You can compute this, it gives minus j20 ohm. Z2 is a resistor, so the value remains the same, 30 ohms. Z3 is j omega L, since it is an inductor, so j times 50,000 times L, 1.2 milli is 10 to the power minus 3. So this is equivalent to j60. Okay, so the question, what is V0, right? Well, if you look at this circuit, then actually we can use voltage division. You see, so the voltage V0, since this inductor is parallel with this resistor, then the voltage across this inductor is the same as the voltage across this resistor, so this is also V0, right? So we can use voltage division. So V0 is nothing but, let's do the analysis in a frequency domain. So Z2 parallel Z3, and the total impedance is Z1 plus Z2 parallel Z3, right? What is Z2 parallel Z3 is actually 24, right? Because Z2, okay, let's write it for you. So 30 j60 over 30 plus j60, right? So the same with this one, minus 20 plus 30 j60 over 30 plus j60, and this is 24 plus j12 minus j20 plus 24 plus j12. So I should multiply this with the Vg, right? Vg. So 24 plus j12 over 24 minus j8 multiplied by Vg is minus j40. So this gives 30 minus j34. Okay, so we have found V0, but this is in frequency domain, and the question is, what is V0 in time domain, right? Because it has t, so V0 of t. What is V0 of t? Well, V0 of t is the magnitude, right? So you can write this as 31 minus j v, right? So square of 30, the angle is the inverse tangent, always use a tan 2 minus 30 comma 30, and this is equal to 42.43. Oh, sorry, I made a mistake, so it's not square of 30, right? And square root of 30 squared plus 30 squared, actually minus 30 squared, and this is the same, 8 10 2 minus 30 comma 30. All right, so this is equal to 42.43 cosine. Since the frequency doesn't change, we have 50,000 t, and then the angle is minus 45. So 8 and 2 minus 30 comma 30 is minus 45 degrees. Okay, fault. So this is the answer, and be careful with the notation because we know that this is in radian per second and t is in seconds. So if you multiply this frequency with t, you get radian, but this is degree. So the unit doesn't match, right? We have radian here but degree over there. So if you want to mix the radian with degree, don't forget to write the degree symbol right here. Otherwise, if you don't write it, then it means that this is 45 radian, not degrees. Okay, so that's the first problem. Second problem, it's a simpler one. I have again phi as this is resistor 4 ohm, 240 millihenry, capacitor 2.5 millifarad, and the question is what is I0. So I0 is the current flowing through this circuit, I0 of t. So what is I0 of t, given that Vs is 100 sine 50t millivolt. Okay, so the strategy here, so we compute the total impedance and then the current by using Ohm's law, and then the current is voltage divided by the total impedance, right? So first, the voltage is, again, let us represent it with cosine. So 0.1 volt cosine 50t, then minus 90 degrees volt. So this is equal to minus j 0.1 volt. Okay, what is the total impedance? Z total, you know, that is 4 plus j omega L. So j omega 50, L is 0.24 plus 1 over j 50 times the capacitance, which is 10 to the power of 3, because we have millifarad there, so 2.5. Okay, so this turns out to be 4 plus j, 4 ohm. Therefore I0 is Vs over Z total. Vs is minus j.1 over 4 plus j4. So you can compute that. It is equal to 0.0177, and the degrees is minus 135 ampere. Okay, again, this is not the final answer because this is the current in frequency domain. We need current in time domain, so I0 of t is 0.0177, right? Cosine frequency is 50 minus 135 degrees amperes. All right. Okay, now let's move on to the final problem. This is a little bit more complicated. So I have a current source. Again, everything is sinusoidal or AC, AC voltage, AC current, inductor, resistor. Inductor is, so it is given the impedance instead of the value of the inductance. We have impedance 500 ohms. Current is IA, so let me IA here is capacitor with resistor. Again, we have the impedance minus J 1000, 2000 ohm. This is IB. Resistor 1000 ohm and voltage source J50 volt. The current flowing through here is IC. Okay, now we know it is given that IB is 25 milliamps and omega is 1500 radian per second, and the question is what are IA of t, IC of t, and IG of t. Okay, so how do we solve this? Okay, first let's see what do we know. So we know that IB is 25 milliamps, so IB is 35 milliamps, and we know the impedance right over here, which is 2000 minus J1000. So by multiplying the current with the impedance, we know the voltage across this branch right here. So notice that they are in parallel, so the voltage across here, say VB, right, is the same as, say, the voltage across here, VA, right? Okay, now let's compute VB first. So VB is IB multiplied by, say, ZB. So IB is what? Is 25, so 0.025, right? And zero angle, okay, doesn't matter. And we have 2000 minus Z1000. This is equal to 50 minus J25 volt. Okay, now we know that VA is also 50 minus J25 volt. Therefore IA is VA over ZA, which is 50 minus J25 over ZA. So what is ZA? ZA is 500 plus 250, J250, right? Which is 60 minus J80 milliamps, and it is equal to 100. Angle is minus 53.13 degrees milliamp. Okay, how about IC? So IC is VB minus J, right? Minus J50. Why minus J50? Because we see that the sign here is flipped, so this is equivalent to plus minus with negative sign, right? It's the same thing over the total impedance here, which is 1000. So 50 minus J25 plus J50 over 1000 is 50 plus J25 milliamps, which is 55.9, and the angle is 26.57 degrees milliamps. Okay, last we need to find IG, but you can see that IG is IA plus IB plus IC, so IG is IA plus IB plus IC, which is 60 minus G80 plus 25 plus 50 plus J25, which is 135 minus J55 milliamps, and that is equal to 145.77 with angle minus 22.17 degrees milliamps. Okay, but the question is the values of IA, IC, IG in time domain. So we need to convert it into time domain. I of t is 100 cosine, and the frequency is 1500. So 1500 t minus 53.13 degrees milliamps. IC of t is again 55.9 cosine 1503 plus 26.57 degrees milliamp, and IG of t is 145.77 cosine 1500 t minus 22.17 degrees milliamps. Okay, so these are the final answers for problem number 3. Okay, so it's pretty simple. Again, if I'm not clear of, or you have questions for me, please send me email or come to my office hour, which is every Tuesday at noon. All right, thank you for your attention, and I'll see you next week. Thank you.